So we're making a continuation from the previous question that we did. We're still maintaining question 5, tutorial sheet 1. So we're looking at the second question, which is part B. So we're going to finish the rest of the parts. We're looking at part B, then we're looking at part C, and then the rest of the questions. So I love to look at this reaction mechanism. It's one of my favorites so far. So we're having an halide here. In fact, not an halide. We're having a halide here. Okay, we're having a halide here, and we're trying to see how we can come up with the major product after reacting in the presence of this reagent that has been given here. So one thing that we must know here is that the end product is very easy and straightforward. We're just going to have this part here, right there, getting the oxygen and putting this long carbon chain. So our end product is nothing like but this. CHCH3. So this becomes your answer. But the question is how did we get there? That is why I want to bring in now what we're calling the reaction mechanism. So this is how you proceed with it. Let's move on. So we are having our reactant here as this, and then in the presence of a reagent, and this reagent is PH3. I'm going to write the structure in terms of okay, I'm going to write it as PH3. This is a phenyl group. The phosphorus is there, which is double bonded to the long carbon chain CH CH3. So that's how it works out. So for me to react this, and for me to make this reaction very possible, I am going to split this, or trying to come up with a resonance structure for it. And when I come up with that resonance structure for it, I'm going to write it in a different form to make this whole thing very suitable for me to react it with the structure that has been given here. So this is how I'm going to proceed with it. The structure is going to be like this. I'm going to split this bond. This is a double bond. So I'm going to split one bond here and making sure that the number of electrons, or the lone pair of the lone pair electrons attached to the phosphorus as well as to the carbon. So we're going to have that, and we're also going to have that. So upon doing that, this is the overall structure that we're going to have. We have our carbon here, double bonded to what? The phosphorus, with the lone pairs of electrons there, because you know this bond here is made up of two electrons. So these two electrons are now attaching on the phosphorus, just like I indicated here. These two number of electrons here are attaching on the phosphorus, and I'm indicating them there. And this phosphorus is attached to three phenyl groups, which is PH3. And then we're having our carbon here, which is attached to the one hydrogen, and also we have another carbon which is attached to what? Attached to three hydrogens. So this has one, the other one has one, two, three. Remember the lone pairs of electrons here that we also that came from this bond that was there. So by doing this, we're making this structure very possible to react with the initial structure that has been given. So this is the reactant that we're having. So we are reacting this in the presence of this structure here, which is the halide. Okay. So now one thing that you must understand is that phosphorus is able to bond to how many structures? it is able to bond to four structures, okay? In fact, phosphorus is able to bond to three structures. So you have phosphorus bonding to the pH3 here, and the pH3 they're saying that three phenyl groups. Also pH3, also pH3. But what has happened here is that phosphorus is bonding to four groups plus the carbon there. So it's going to, and it's also carrying the lone pairs of electrons. So what will happen is that the phosphorus is going to be positive charged. So this phosphorus is going to be positively charged. So this phosphorus is going to carry a positive ion. There we go. And then because the negative, because of the carbon here, which is carrying the number of the two electrons, we expect this part of the to be negatively charged. That's it. Okay. So this carbon here, we're going to have an attack. We're going to have an attack where we are going to have the carbon here, which is negatively charged, attacking the bond which is connecting to the oxygen. So we have the carbon here, which is double bonded to the oxygen. So this carbonyl group is going to be attacked because this is partially positive, or this is partially negative, and this is partially positive. So after attacking that, we're having this structure. So remember our initial structure that we have is this structure here. We're having that, we're having that, we're having that. So after attacking this, we're also going to have the double bond which is bonded to the oxygen here also breaking. So we're going to have that coming there. So this now becomes a single bond which is attached to what? To the oxygen. And you know the number of electrons which were making the double bond here moved from this part attaching to the oxygen. So we're going to have 1, 2 there. We're going to have 1, 2, 3. And because it has how many? There's 1, 2, 3, 3 pairs of electrons. You expect that this oxygen is going to be negatively charged. So now there's a part. Remember that this oxygen here was attacking there. So there's a bond here. And don't forget the other one that we're having there. We have the methyl group. And then the bond that was attacking is going to go straight there. So let me change the color for you to be able to see. It's attacking straight there to the carbon. And this carbon here is attached to how many hydrogens? It's attached to 2 hydrogens. I mean to 1. It is also attached to another carbon, C, which is attached to 3 hydrogens. So 1 here, 2 there, and 3 there. The other thing that we're having here is we are going to have a part where we had this structure right here, because remember that there was a bond that was coming from the carbon, this carbon that is here, which was attaching directly to the phosphorus. So we still have this as well, the pH there, and then it had 2 pairs of electrons, and this was negatively charged, and is attached to what? To 3 pH3, 3 phenyl groups. We have it there. So now one thing that you can see from this structure is that this carbon, this oxygen here, is negatively charged. So it's going to attack the phosphorus, which is positively charged. So there will be an attack here. So this oxygen is going to attack the phosphorus, which is positively charged, and the end product is going to be this. I still having that structure, there, and then remember we're having the oxygen there, which is now bonding to the what? Bonding to the phosphorus there, and the phosphorus is also bonded to 3 phenyl groups, 3H3. This same phosphorus is bonded to the what? To the carbon, right? Yes. And remember here there's a bond we had a methyl group there, and then there was a bond which is attaching to the what? To the carbon there. And then we're also having this carbon had one hydrogen, and it is also bonding to another carbon which is having three hydrogens. There we go. So we're having that structure there. What's the next thing we're supposed to do? We're supposed to understand that the electronegativities of these compounds are different. This oxygen here has got a different electronegativity. The phosphorus here has got a different electronegativity. There's a carbon here having a different electronegativity, and the other carbon here having a different electronegativity. So these electronegativities determine the number of electrons that that compound or that element is determining the number of electrons that that element is able to hold. So for example, we know to say the electronegativity of oxygen is 3.5, while the electronegativity of carbon here is 2.5, and then the electronegativity of phosphorus is 2.1, and then the electronegativity of carbon here we're saying is 2.5. So this carbon here is more stronger, as it's more electronegative as opposed to the phosphorus that is here. So we're going to expect that the number of electrons are going to move from the phosphorus joining onto the carbon. So there will be a bond breaking there. So we're going to have this bond here coming to something that is more electronegative. This is 2.5 and this is 3.5. So it means that this bond here cannot carry more electrons. They can only be taken to the oxygen because it is more electronegative as opposed to the carbon here. So we are going to have a shift which is going to be there. So this bond is going to break, and this bond is going to come and join here, forming the what? Forming a double bond, attaching to the oxygen, attaching to the carbon, which only has one hydrogen, and attaching to the other carbon, which has three hydrogens. And then we're going to have this structure here leaving us because this bond here is breaking, and the oxygen is joining together with the phosphorus, which is also attached to three phenyl groups. Great. So our final structure here is this. We're having our bond, our structure there, and then we're having down there, and then you know that this group is not there. I'll still maintain, I still have, remember, we had our methyl group there, still going to maintain, and then right here, we now have a double bond, which is bonding straight to the CHCH3. So this becomes our final structure. The other product that we're having in this solution is the O, which is attached to the P, and the P is attached to the what? To three phenyl groups. So having this other structure in the compound. So this is how this O reaction mechanism works out. I first of all want you to understand that it's not really very difficult. It's easy. And there is one of the reason why this is one of my favorite mechanisms so far, because it's easy. You just have to follow the steps. So the steps are quite easy. Just see how we can work around them and go through this video once more so that you can have a better understanding and overview of how you're supposed to go about this reaction mechanism. So remember the steps. I first came up with a resonance structure suitable to react with a reactant that was given, and then I went on to proceed from one step to the other until we came to this structure, which is right here. So this is how it all works out. Thank you, and let's look at the other questions in the video.